In this video, we will talk about probability. So we define probability as the science of chance behavior. And chance behavior is unpredictable in the short run, but predictable in the long run. So think about flipping a coin. If you flip it once, it's unpredictable what it's going to be. But if you flip a coin 1,000 times, you'll find that about half of those coin flips are heads and half are tails. And the longer you flip it, the closer you are to 50-50. And that's what we mean by regular and predictable in the long run. So that's why we can use probability to get useful results from random samples and randomized experiments. So if things are random, remember, the individual outcomes are uncertain, but there's a regular distribution of outcomes in a large number of repetitions. So again, like the coin flip, it's random, whether it comes up heads or tails, but there's a regular distribution of those heads and tails in a large number of repetitions, about half and half. And we call the relative frequency of an outcome when it settles down in the long run, the proportion of occurrences. So say you flip a coin 1,000 times and 500 of them are heads, that would be the proportion of occurrences of heads. And we define probability of an outcome to be that relative frequency over the long run in a very large number of trials. Now we can observe a long series of independent trials. That means one doesn't depend on what the last one did. And by that we can determine relative frequency probabilities. You do it with many samples. It's best to do it with simulation, either on a computer or using random number tables. So coin flipping is a great example. Obviously, here's a chart with the proportion of heads and tails. And so it shows in the short run they're really far apart. But notice as they get close to 5,000, they're right there together. You can't even tell which is on top there. Okay, so it's over time they kind of converge to that 0.5 line. So we can construct probability models, and that just kind of shows us overall what's going to happen and what the probabilities are of each of those things. So we have what we call a sample space, and that's all the possible outcomes that there are. And then we define a single event as an outcome or set of outcomes from the sample space. So you have the set of all the possible outcomes, and then you take one of those and you can call that an event. You can take two different ones of those and call that an event. You can do different combinations. Every outcome or set of outcomes you can make is an event. And a probability model then is a sample space, so all the possible outcomes, and a way of assigning probabilities to the events. So a method for being able to say each of the possible events occurs with this probability. So a good example of a probability model is if you roll 2 dice. So if you look here, you'll see that everything in here is all the possibilities for rolling 2 dice. So that's your sample space. And one event might be rolling a 3 and a 1. Another event might be rolling a 4, where you can roll a 1, then 3, a 2 and a 2, or 3 and a 1. Those are all the ways to make a 4 by rolling fair dice. Now each of these individual dice rolls has a probability of 1 out of 36. No one is more likely than the other. So each of them are 1 out of the 36 that there are. And this is a probability model. It's the sample space and a way of assigning probabilities to every event within that sample space.